Lesson 27, Quadratic Applications. In this homework assignment on question numbers 3, 4, 5, 6, and 7, you are allowed to use a calculator for calculating values. We don't encourage you to use the graphing side of it, but you are allowed to use the actual calculator's home screen to calculate values. So just to be clear on this. In this lesson, you're going to get some word problems. So let's go over some of the things that I've seen as most problematic for students. On question number 3, the question's going to give you an equation, and it's going to explain some stuff about a slingshot being launched. It's launching a small rock with an initial velocity of some sort of feet per second upward from a cliff of some certain height. This is going to be the graph of what you have. So in your homework, it might be helpful to sketch this graph. Notice that I labeled some points in colors, so we'll talk about the pink one first. In the word problem, if it tells you where the initial height is, you're going to know that that's immediately your C value of your equation, or your H sub 0, the initial height. In terms of the vertex, they don't give you the vertex because they do give you the equation in standard form. So you could calculate the H value by doing negative B over 2A, and then you could see what H is and then find K. And then it's going to ask you on the homework, how many seconds after you launch it does the rock hit the ground? So the green point is where did it land on the ground? And you're being asked the time. So this is a helpful diagram to help you with number 3 and to help you with number 4. So number 4 is talking about a stretch of a highway in a valley. So imagine that this graph is showing you the valley part, and you want to install a storm drain on that highway at the lowest point so that we don't flood the roads. They give you an equation in standard form with all of the values, A's, B's, and C's. So again, you know the C value is 0, C. You know that y-intercept. And then to determine the H and K, remember, to determine H, given standard form, you do negative B divided by 2A. And then to find the K value, you would plug in to your function negative B over 2A. They're asking you in this problem for determine the coordinates of the storm drain to the nearest unit. That means they want the H and K value, and they want it to the nearest unit. With that said, you do want to think about the fact that when you find H and K, you can use your calculator. I'm not expecting you to do this by hand. This is an asteriskeded problem, so use your calculator. Okay, so let's do some examples. So example 1. Imagine you have a rectangular area and it's enclosed with 120 meters of fencing. You also have a stone wall as one of the 4 sides. Because we're dealing with a rectangle, we know we have 4 sides. And it's really helpful to draw a picture in this case. So I'm going to draw a picture. I'm going to think about the fact that I have a rectangle and a stone wall. So I'm going to make the stone wall look like little stones. And then I'm going to build a rectangle around that. Remember, we know that we're building a fence. So I'm going to show the fence. The fence is like my blue little marking here. This is my fence. I'm building a fence around this. And what I know is that it's going to enclose an area, a rectangular area, and I have 120 meters of fencing. Notice the unit is not meters squared. If it was meters squared, we'd be talking about area. But because we said 120 meters, we know we're talking about perimeter. So the perimeter is equal to 120 meters. What we need to do is find a function a of x that expresses the area of the function in terms of x which is the length of one of the sides perpendicular to the stone wall. So they just gave us some info. They literally told us how we're going to label each side of this diagram. The length of one of the sides perpendicular to the stone wall is this guy X and that guy X. Now I don't know the longer side. So I'm going to use a different variable and I'm going to call that Y. In terms of perimeter, normally perimeter of a rectangle is 2 sides added plus another 2 sides added, but I don't have fencing for the stone wall because the stone wall is already built. So we know that we have 2 X's plus 1 Y is equal to 120. I'm going to solve for Y so that I have my equation in terms of X's. I want everything to be in terms of X's because they're asking us to write an area function in terms of X. So if I were to rearrange this equation, I would say Y is equal to 120 minus 2X. And then to answer part A of this problem, well, we have to think of area of a rectangle. So the area of a rectangle is equal to, typically say, the base times the height, or the length times the width. Either way, works both the same. In this case, we have values for this. So we have X, and then we have Y. Y is going to be replaced with 120 minus 2 times X. Now this is in factored form. So factored form quickly gives us zeros of our equation. So before I even make that a standard form equation, I'm going to sit there and think, if I were to zero product property that statement, if I were to set 0 equal to X times 120 minus 2X, I would say either X is equal to 0 or 120 minus 2X is equal to 0. From there, I know that one of my zeros is here, and then the second 0 I have to solve, do some solving, so I get 120 is equal to 2X, 60 is equal to X, so I have this 0 here. So I have 0 comma 0 is 1, 60 comma 0 is another. Well, that's information that I need because now I can quickly deduce what my axis of symmetry is. Remember, to find the axis of symmetry when I give the zeros, it's directly in the middle. So I know that in the middle of 0 and 60 is this great number called 30. So I know when X is 30, I have a maximum happening up here. So from here, if I think about this function I just wrote an equation for. I wrote an equation for the area of my rectangle. So I can label this left side called the area. And then I can label the base side, the X side. This is X, which we know what X is because I underlined it in blue up there. It's going to be the length of the side. It's the side length that is perpendicular to the stone wall. Okay, that was just from looking at the equation. So now let's go back to the question. Well, we've answered part A. It says write a function that expresses the area of the function of X, the length of the side perpendicular stone wall. Done. Part A is check. Part B says we need to find the maximum enclosed area of the dimensions of the rectangle that maximizes the enclosed area. Well, we know that the maximum happens at the axis of symmetry of X is 30, but what is the max area? So that's the question for part B. The max area is the K value. So we need to plug in 30 to our function and then solve for the max area. So I'm going to say we have, in this case, I'll do A of 30, which equals 30 times 120 minus 60, because 2 times 30 is that. In that case, we get 30 times, well, 120 minus 60 is 60. 30 times 60 is 1,800. So I know that the area when the side length perpendicular to stone wall is 30, the maximum area is 1,800 meters squared. Now, it didn't just ask for the maximum area, it asked for the dimensions of the rectangle that maximizes the enclosed area. So I gotta go a little further with that. I gotta understand that I know that X value is 30, but what's the Y value on the actual picture? So if X is 30 on one side and X is 30 on the other, that means I have 60 of the total 120 for my perimeter, so Y must be 60. So my dimensions are 30 meters by 60 meters. Okay, and then I go back to the question. C, give a realistic domain and range for this function. Well, if I look at my actual function that I'm seeing, what I have calculated on my screen, I have a really good visual of domain and range because I have my picture. So for part C, what I need to think about is domain. Normally for quadratics is all real numbers, but I can't have a distance be negative. So we know we have to start the domain at 0, but if I had a domain at 0, would I have an area that's actually enclosed? The answer is no, so I'm not going to include 0. What is the maximum X value that it could be? Well, that's 60, but again, in that same logic, if 60 was my domain, if I equaled 60, would I actually have an area that is enclosed that it creates a rectangle? The answer is no, so we don't include 0 or 60. In terms of your range, that's saying what is the maximum area you can have? Well, we know we can't have a 0 area because we don't have an area, so 0 is our lowest. And then what's our highest area? Well, we calculated it was 1,800, but we can have an area that is 1,800, so we include it. Okay, there's example 1. I think my next slide has that, so I'm going to skip it again. Into example 2. So for example 2, it says the height h of t of a ball in feet above ground, t seconds after it is thrown, is given by the function h of t is equal to negative 16t squared plus 80t plus 100. I gave you some information you might not know unless you're in physics. If you don't know this, and that's totally fine, the b value, anything associated with the x, or in this case the t, the single variable, not the squared variable, that number is known as your initial velocity. So in this case, I had a ball. I was at a certain height. Remember, we talked about heights are our y-intercept. So we're at 100 feet off the ground. And I have something that's helping me throw this ball, or maybe I'm just really good at throwing, with an initial velocity of 80 feet per second. The negative 16 counts for gravity. So gravity is negative 16 feet per second. And if we talk meters per second, it's 9.8 meters per second that's negative, forcing us down on Earth. Again, physics things not necessary to remember for this class, but just info. In terms of this question, again, I would start with drawing a picture. What do you know? So we know that the x-axis is represented in this case as time, and our unit is seconds. In terms of our y-axis, we're dealing with height, and our unit is feet. We know this is going to be a negative parabola because we're starting at negative a value, so we have that negative 16t squared. We know our starting point is at 100 feet. So we could claim that that red dot, we know that coordinate is 0, 100. I'm going to move where it says height so I can write that in. So we know the red dot is 0, 100. And again, we know this parabola is going to go In terms of this parabola, there's some things that we might need to calculate. So we probably are going to need the max height, which is going to be the h and k. It's also probably going to ask us, when does it hit the ground? That's going to be the x-intercept. And then it's probably going to ask domain and range. So use your picture to answer those questions. Okay, so let's look at question A. Question A says, what is the ball's starting height? Well, that's given by our actual picture or by the equation. We know the starting height is 100 feet. How do we know that? It's either the C value that you're looking at, or you can look at your graph. Plain and simple. And question B. What is the ball's maximum height? Remember, maximum height is going to be the k value of the function. So if it was in vertex form, we'd be easy answer. Since we're not in vertex form, we might have to do an equation. So one thing you might want to think about is we could calculate the axis of symmetry. So we could get this x value. And once we have that x value, it gives us some information so we can get the max height. So with standard forms, to calculate the axis of symmetry, it's negative b divided by 2 times a. So I'd say negative 80 divided by 2 times negative 16. In this case, when you calculate that, again, you can use calculators on some of these questions, so grab your calculator, use it. You're going to get the value of 2.5. So we know that the maximum height is occurring at 2.5 seconds after we throw the ball. Now, where is that maximum height? Well, I'm going to go to h of 2.5. Again, I'm going to use my calculator to help me with this. Negative 16, parentheses, 2.5 squared, plus 80 times 2.5, plus 100. So I'm on my home screen. I plug all that into my calculator, and I get this number 200. So I know that if I wanted to add to my picture, I have 2.5 seconds happening at 200 feet. Okay, so now to answer this question, the ball's max height, the max height is 200 feet. Okay, so that's part B. Part C is asking us, when does the ball hit the ground? I'm going to go to the next slide so I can have some more room on how to solve this, but I'll bring my picture over so that I have that to reference. So, when does the ball hit the ground is that x-intercept. Remember, I'm looking for that x-intercept. So to get that x-intercept, that value of that landing point, because it's in standard form, you could either factor or complete the square or quadratic formula. I'm going to pick quadratic formula. So remember, I'm using the formula x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. When I plug in my thing, plug in all my info, I got negative 80 plus or minus square root of 80 squared minus 4 times negative 16 times 100, all divided by 2 times negative 16. I'm going to split my calculator into two equations. Like I'm going to do one with a plus sign, one with a minus sign. So this will be my plus of the radical, minus of the radical. And when I do that, I'm going to get two answers. I'm going to get 6.035, and I'm going to get negative 1.035. Remember, this is representing an x value, which is the time. Now, logically, can you have negative time? No, you can't. So your answer must be 6.035. So the ball hits the ground. The ball hits the ground 6.035 seconds. Okay, the last question of this example is asking us about that domain and range. So part D. The domain, again, we're talking about time. So where can I start? I can start at 0 seconds because I know I'm at 100 feet. Where do I land? 6.035 seconds, and that's inclusive on both ends because I can be those statements. In terms of the range of this function, the lowest height my ball can ever get to is when it lands. That's at 0 feet. And the highest it can ever get to is the maximum, which again on my graph says 200 feet. And that's that. Folks, that's the lesson at its finest. Have a great day.